Okay, here we are. We're going to be working on the rotor. So this is an actual bearing surface. So not just that the race would slide onto this, but this is actually the surface that the rollers run on. And so of course this got separated from the gear case years ago and now has corrosion on this surface, even though it's supposed to run on these roller bearings. Now, if I measure this, of course it's larger in diameter because the surface rust has built up and oxidized on this shaft surface. And of course, that's not a healthy bearing surface. I did have, when I got the new bearings, I was able to get, here, let's see if we can see this. This is the bearings. It's kind of cheating. This is the bearings tolerant, or so this is the bearings dimensions. So we need A. So A is 1.2661. So if I measure this shaft right now, that shaft is, I don't know if you can see. I'm going to use the ratchet end to try to be very consistent. But so here's a lesson on micrometers. So 1.12, and we're at 1.12, and there's the little ticks. 25, 50, 55, 60, 65, 66, 67. So we're at 1.267. And then of course if I buff this, it has to be smaller because of course the material is gone in the form of the rust layer or the oxide layer. So now I have to be very careful how I address this surface. Obviously it needs to be, polished in order to run these roller bearings. Now another option is to get a different bearing with a race and machine this diameter down to match the new bearing. But now we're getting into potentially a strength issue and a size issue because of course this is the gear, or I guess this is a splined gear that runs on here. So I think we're going to just take some tests. Now I did a preliminary buffing with a very, very kind of light buffing to see if we could just polish some of the oxide layer off. And so I'm going to do it on both sides as a test and just see how close we get to our theoretical or our nominal size of what the bearing is calling for. Now this bearing, the old bearing, of course, was all corroded because it sat open to the elements, and if I try to put this bearing on there, it's of course basically trying to rub the rust off. So I don't want to do that. So we are going to try to just take a shot. So I've just carefully buffed this side where there can be no material removal, even though the oxide layer or the rusting action has taken some material off. So I'm going to just do here, and I'm going to do right here. And again, just a very, very light polishing. I don't even want to use emery cloth because every bit of material that we lose is of course going to change the longevity of the bearing. So So we're still big in diameter. So again, 1 and 1, 1.1, 1, 2, 25, 50, 60, 65, 66. So, I mean, hard to say how a guy addresses this shaft. I mean, it has to be a near perfect finish in order for the bearing to have any length of time in operation. So yeah, kind of a tough spot. I haven't cleaned these guys yet, but this is kind of where we're at. So I may just buff around and see how it feels, see how close I can get. We might put it in the lathe, true it all up, and see how close we can get. But I thought I would just start with trying not to remove any material other than the oxide layer, and see how close we can get it and see how the bearing fits. This guy too, he's even thinner wires than this. I mean, it would on the lathe it would only take a split second of emery cloth or a file, and you'd be undersize, and then you'd be in a position where we're gonna. This is hardened to the point where it's as hard as the gears. So this has either been induction hardened or it's through hardened. I'd imagine it's induction hardened just because they need a certain amount of toughness inside this shaft, but they're not selling these on the shelf anymore. So I don't know. I mean, when I first got the bearings, the parts that came were sealed bearings with inner races. So I could conceivably, so this bearing is identical in dimension to this bearing as far as its width and its OD, except it just comes with an inner race. It's just a ball bearing. But I mean, do I try to machine through this hardened shaft to put this bearing on? I mean, it slides over the gears, or this gear, but it's like, yeah, I don't know. It's a tough call. It's a tough call. Okay, I don't know if you can see this. I just want to show you this. So just really carefully, just rubbing it, you can see how much surface rust or corrosion is still on there, even after giving it the light buffing. And I don't know, I mean, that oxide layer can't be on there, because that'll just turn into a wear. Abrasive material in the oil, but of course scratches from a sawzall blade aren't exactly healthy either. So I don't know how much we're actually going to get. Or if I just stop agonizing over it, buff it, put the thing together and run the scraper, because it is of course a scraper. And but I just you don't want to be that guy that says it's good enough and slams it together, and then in a month from now silver oil comes out because you ruined it. So yeah, tough decision. Part of the problem with spinning it and using emery is this right here is the factory height, and this high spot, for example, where the rust is, the emery is going to rub the high spot, but it's also going to rub down into the factory surface and take away from the factory surface as it tries to take the high spots. Now we could try to dial it in perfect if we could find, if we could find some original face that doesn't have corrosion on it, to see if we could get that to see if we could get it to dial in. And then with a carbide insert, maybe you come along and just take the high spots of the rust off and then polish it. There is something to do with, depending on the RPM of the bearing, the bearings to races need a certain amount of clearance in order for them to heat up, expand. And so this is a fairly high RPM, because it's I think it's this one's 3600 RPMs, so that's a fairly fast RPM. So there has to be clearance in the races to the rollers in order for expansion. And so I know that there's like some charts and stuff that talk about how much clearance, and in the past I've put together some gearboxes and whatnot, and there is some click, you could say, because of the high RPM factor. And I mean, yeah, hard to say. Maybe we'll just give it a little bit of a scrape, and then maybe we will put it in the lathe and see if we can polish it. And I'll see if I can do some reading and find out how much clearance we're supposed to have. That nominal size, or that size from the bearing chart, is what the bearing's supposed to be. But I'll have to find out how much clearance the shaft size is supposed to be, because there has to be clearance, some amount of clearance. Anyways, more to ponder. I think we're beginning to see where the seal ran. I think that might be where the seal must have been. Maybe that's where they actually, right from about here to about there, I bet you is where the bearing runs. Or maybe this is where the bearing runs from here to here, and the seal has to be on this side though. You can hear that rust coming off. I can actually see, it's kind of hard, you might not be able to see, but in the glare I can actually see turning marks. This feels really good right here. This rusty part, it's actually, you can see the dust come off of the iron oxide, and then once it's off, boy, you can really feel it's way smoother. But maybe this is the way to go, just nice and slow. We'll keep polishing this, and hopefully the edge of this is enough to just kind of shatter off the iron oxide, but not remove any of the steel. I mean, this is super hard. I don't know if a file would even touch it. Maybe a guy could have got away with using a file on here on the lathe, but I think we just take it really slow. And okay, so after careful buffing and scraping, I was able to get this shaft cleaned up and polished. Now, it actually looks really good, and I think there's a bunch of different factors here. I think because of how hard the shaft was, it didn't corrode as fast. I don't know if that's a thing. I kind of feel like it is. Also, I think maybe it just having just condensation, as the corrosion kind of limited how deep it got, and I can actually see original machining tool marks if the glare is just right. You can also see right here, this is where the seal ran, this is where the bearing ran. So there is about a half a thou difference from where the bearing ran to where the bearing didn't run. And if I mic it, it's very close. It's very close to 1.2, 25, 50, 60, 65. So I couldn't find the exact, it's difficult to find online, bearing roller to race tolerances. And I'm not talking about press fit tolerances of the race to the bores or the shafts. I'm talking about what a manufacturer has for the clearance in between a bearing, a roller bearing, or a ball bearing for that matter, a roller bearing and the actual race. This guy, this motor is 3600 RPM, and I think that, oh, this is the wrong bearing, sorry. I think that the, excuse me, I think that the, so this is the new bearing here. This is the the identical bearing to what the original one. It's even the same brand name. This must be old stock, because it's still called a Bauer, and I think Bauer was taken over by, but it's very good on there. And I mean, there is a bit of movement, but it's very slight. Regardless, it's going to go back together, and this shaft turned out really nice. And here's the new seal. This guy will go on there. I'll put some lubricant on there first. But anyways, so I'm really happy with how this turned out. I don't know if you guys can actually see, but there is no pitting. And it is very, very smooth. And this again was all just done with just kind of roughly scraping it and then just polishing it with a fine wire wheel. So I think this is going to be just fine. I buffed these gears a little bit, and I'll buff the rest of the gears and make them look shiny as well. But anyway, it's coming along. I'm going to buff this next. I'm just going to buff this again. I'll give it a light buffing. As long as there's no contact, the surface rust really isn't that big a deal. So I'll just give this a quick buffing and clean this up a bit here, and then this guy's he's ready. Okay, we're on to the electric motor side. So this is the bearing race retainer, I guess you could call it. Now it had, this was a greasable bearing, and this is the grease zerk that would have then greased this, but I opted to get just a sealed bearing, and so I took the grease zerk out. But these spacers were in there to act as kind of a grease shield. So I'm going to put the internal spacer in there. There was another spacer that acted as kind of a, it went over top like that. But I think what'll happen is, you know, I think I might have to put them in there, because just looking now, they load up the inner race gets loaded up by these guys, and the outer race gets loaded up by these larger ones. And even though it's not gonna sling grease, it's still, so this guy goes here, there's enough clearance to the seal, but he presses on the inner race, this guy presses on the outer race. This was their kind of crude grease seal, I guess. And then the outer race gets pulled tight against this block, and the inner race gets this adjustable nut. So we have to put these spacers back in. So we'll put this guy back in, then this guy, this guy, then this guy, then this bearing, then this guy, and then one more spacer. And then we can slide him onto the back end of the housing of the, I'll have to get that. How does that slide in there? Oh yeah, okay, we'll just put that in there like that. Now we should be able to bring this around. This guy should just go right in there. There it is. Now we got to line up these bolts. We got to line up these bolts with that retainer in there. It's going to be kind of tricky to see. Oh, there, I can see the... I wonder if I can get in there with something. Oh yeah, there, that works. We'll just do this. Oh, look at that, I got it. Okay, well that's coming together nice. Now, on this end, there is this big nut goes onto this spline unit. This guy goes on here. But first we got to tighten up those Allen head bolts. Okay. Okay, so I put it together wrong. I needed to put this whole bearing pack together with this, with the back outer bearing bracket, but I needed to put the inner race retaining nut on first. I shouldn't have put it in there into that housing yet. I got to put this on first, tighten this up, and then I can put it back into that housing and bolt the bolts through. So this guy, he just needs to tighten up the inner race of the bearing to the shaft, and then he's got that little keeper that will lock him in place or keep him in place here. Let's just see now where we're at. Yeah, okay, so you can see in the shaft there's the half round, and then there's the other half round. So I think if we just end up giving this a few taps, that should load up. That should load up the inner race of the bearing. Got my hammer under here. There we go. Bigger hammer. So we'll just give this a there we go. And then this guy just goes in there. Now, this guy goes back in there, but apparently this guy, look at that. So you see how he's actually bottoming out on the taper before he's hitting that little pin, but that pin is unable to come out because of this guy here. But he actually runs into a taper right here, so it doesn't actually press against that. Now all of this goes into this guy now, and now we put these bolts back through to catch the outer race. So my bad. There we go. Now we can. Last time we had to spin this guy around. Oh, it's very close. I can see it right there. There we go. Alright, let's spin this around. Okay, that's better. Now, okay, look away. I'm using a tool improperly. Let's just see in there. Now that bearing, this bearing is also a twin row roller bearing in order to manage the thrust that's created by this guy. So yeah, that was so that bearing we just installed, he's sealed, but yeah, he's got two rows of ball bearings to manage some of that thrust action. Now, I think we're just going to leave it here because I'm not going to put the brakes together just yet. But we will go ahead and put this on to the housing now. So, okay, here's the top, here's the top. I'm gonna slide this guy through. I buffed this primer off. I didn't really like the looks of it, so we'll carefully bring him through. Now, and we can't really stand it up. Let's see if we can. Oh, I've got stuff in there. What's going on here? There we go. Okay. Oh, look at that. Went right in. Okay. Now, wonder. Let's see. I should probably get a rubber hammer or okay, well, that's coming together nice. Now, I don't think I'm going to tighten these guys until I get this guy together. I think we should put this together all as one unit. Maybe one more. Maybe one more bolt down here. Well, first time. Let's bring this around. It's getting heavier. I do want to put a little bit of, I wonder if I could get some shims, although it does look, yeah, I'll get some shims. Okay, well, here we go. I kind of got some blocking underneath here, and we'll see if we can pull this together. Oh, look at that. It's working. Let's do this. Okay, I got some new hardware. Okay. Well, it has been a long time coming for these two components to be together. I don't know how long they were apart. I don't really know much of the history behind how long it was since this machine operated, but here they are going back together. It's pretty exciting. This guy, I don't quite got what it takes. There's a fair bit of gear reduction. So it looks like I still need to get it to go a little bit further in, but let's see if we can get these bolts in and maybe just very carefully snug it all up. Everything feels really free as far as the rotor I don't hear anything touching. I mean, I went out and, oh, it's upside down. Oh, well, there you go. It's upside down. Un momento, por favor. I better just go verify that the orientation. I think this is the bottom on the machine and this is the top for the motor. I might have got ahead of myself. Give me one sec here. Okay, so I need to rotate this, but I thought we could do it up like this now. Okay, now let me see this. Okay, we are good. I kind of looked at all of them out there just now, and they can really be anywhere. It's really just to do with the wiring, and the limit switches come up the one side and the main power comes up the other side. So I mean, we'll just make it look symmetrical. This is the top, so we'll make this the top, and that'll be that. Yeah, it's looking really good. I got yeah, so then this guy, he's this, the last piece to go on is the where did that guy go? Here, this guy. So the big cable spool that runs the eject will go on here. We'll put those on there, put that on there just to protect the threads. So I'll give this a painting once I get this bolted together. I just kind of want to put it together nice and slow so that we can make sure it's, look at that. Make sure nothing's binding or pinching. But it's, yeah, it's looking good. It's looking good. I don't know if I'm going to be able to start the machine. It's bitter cold right now. We're having lows of -30 right now, and I don't know. I don't know if I want to try start it. I mean, I did put that circulating heater pump in it, but at the same time, does it really? Do we really have to start it? Of course we do. Of course we do. But it's so hard on things when it's that cold. Anyways, we'll cross that bridge once we get it installed. Also, I have to go out there and install it. It's not supposed to break by the end of the week, but maybe we can get it installed. So far, though, everything is coming together, and feel lucky that it has been in as good a quality or good a shape as it has been. A couple more of these. There's not much pile left. There's only the springs and a few bolts. So that's a good sign. I got these new guys. When I went to that welding repair store, I was able to get new terminal blocks. This guy, we only really need the 3, but beggars can't be choosers. And then I think there is 4 for the limit switches and for the magnets with a ground. So that's that worked out good. Those turned out they look nice. They'll bolt on to this here. They'll bolt on right here, and then yeah, this side goes here, and these guys tie in there, and then this guy goes here for the for these guys, for the electromagnets. Yeah, it's pretty slow. Oh, I can do it if I... Oh, I can just do it if I get it spinning. Oh boy, that's some crazy gear reduction. This gearbox looks similar to the apron, but the gearbox for the scraper up and down is even bigger, and the motor is an even bigger motor. It's a number 2, whatever that means. There's 4 motors: the eject, the apron, the steering, and of course the main scraper bowl. But the 3 little ones are the apron, the eject, and the steering. They're all number 1 with a I think it's I forget what the gearbox is, but the scraper bowl is a number 2 motor, and it's bigger. It has a way bigger clutch pack or brake pack. I think there's 4 or 5 discs in it, and yeah, it must be a lot bigger, and a lot bigger gear reduction gearbox on it. And so it'll be interesting to see what shape those 2 are in. I mean, we've got this far on this one, and I think it's going to be operational. We'll know here in the next few days if I can get that machine running. But yeah, pretty exciting. Pretty exciting. Looks like this has got to rotate that way. I wonder if I can. Oh yeah, that's working. These guys, I should have probably ran the tap into those as well. I mean, I took these guys out of here, but I probably should have run the tap in there like I did to these ones. But this one hasn't come down yet. Oh yeah, it's not gonna close here. I don't know if you can see that here. This, it's only gonna come down another 1/8 of an inch, but this gap from here to here, there'll always be a gap there. So really we only have a little bit. Yeah, there, we're almost closed there. Oh yeah, look at that. She's right down now. Well, that's working out good. I'm glad I cleaned those threads. They'd been rusty for decades. Oh, there's a thing in the way. Well, I'm sure pleased. This is one of those jobs where it's not fun, like bouncing around in a piece of equipment, but maybe this will be educational for somebody. Maybe somebody somewhere has an old one, and the repair videos, YouTube says do repair, do it yourself, educational videos, but it's tough to get views with working on this particular guy, because of course it's not Caterpillar. My channel isn't big, and most people don't even know about Letourneau, and if they do, they're of a demographic that is seasoned. All the people that know about Letourneau are seasoned. We'll call them seasoned. I fell in love with Letourneau the moment I found out about him, back when I was 17, 18, finding books and anything I could get my hands on. And the more I read about the guy, the cooler he became. And even today, it's amazing, because of course there is going to be a whole bunch of stuff that's going to go hybrid. It already is going hybrid. So he's up in construction heaven, smiling down at all of us who are all the people that are going hybrid. He was ahead. But this is great. I mean, theoretically, this machine, you could very easily put, you know, in 5 or 10 years, when we get our hands on hydrogen fuel cells, this scraper is already set up, and you could very easily, depending on what you get your hands on for an energy source, could make this unit emission free. And I know that kind of goes against everybody's desire to watch old equipment, but I mean, the reality of trying to make money, eventually people that are running diesel are going to get priced out. They're never going to say you're not allowed. They're just going to make it so expensive you can't afford to. And it's going to be the guys that got the equity out of their diesel and got some kind of hybrid and then on to some kind of, I mean, it's not going to be batteries, because batteries aren't going to do construction and agriculture. You're not going to pull a 14, 16-hour day with batteries, but you are with hydrogen fuel cells or with hybrid diesels and batteries. And so this thing is 90% of the way there, which is cool. Anyways, look at that. I think we'll call it good here. This turned out really nice. Look at that. It's even quieter now that it's all tightened up. It'll get even quieter once we get oil in this gear case. Anyways, pretty cool. Pretty cool. Well, there you have it. We got the gearbox together with the motor, and I think it turned out really good. If you look, that just spins so nice, and you look at how much backlash. There's hardly any backlash, considering how many gears are in this gearbox. For there to only be that, I don't think there's a lot of hours on those gears. I know there's some that are pretty rough from the corrosion, but big picture, it's back together and it's looking great. I think it's going to work just fine. So hopefully the next couple of days, if I can get a bit of a warm spell, I'll get out there and get this installed on the machine, and hopefully we can see it move back and forth. So stay tuned, and thanks again for joining me, and we'll look forward to seeing you on the next one. Bye for now.